There are moments in science when the numbers stop behaving like mere numbers and start behaving like messages. 3i, Atlas, is one such message. When I first ran the calculations, the nickel levels, the blue-green emission spectrum, the reverse tail, the non-gravitational acceleration, the 7 jets punching through the solar wind, something became clear. If this object is natural, the odds are about 1 in 100 million. I didn't say that for effect. I said it because the universe left me no other choice. When every anomaly points toward the unlikely, the scientist's responsibility is to confront the unlikely, not retreat from it. But here's the problem. We still don't have the highest resolution images of 3i, Atlas, even though NASA already captured them. They sit archived, unopened, unanalyzed because of what I can only call bureaucratic entropy. And so I've urged NASA publicly, release the data, let the world see the object that just walked through our cosmic front yard. This script is the story of why I said that. This is the story of the 1 in 100 million comet. When you examine 3i, Atlas, you don't see one anomaly, you see 10. Each one is strange. Together, they rupture the baseline expectations of natural celestial mechanics. Let me take you through them the way I explain them to my students. 1. The acceleration that shouldn't exist. Gravity predicts a path 3i, Atlas didn't follow it. It sped up after perihelion without any visible thrust. 2. Sunward jets. The object fired jets toward the Sunday. Natural comets can't do that. They sublimate from solar heating on the sun-facing side, but recoil away from the Sunday. 3i, Atlas broke that rule. 3. Fragmentation or control. During its solar flyby, 7 jets pierced the solar wind at speeds requiring millions of tons of mass flow unless the jets are technological and therefore more efficient. 4. Excess nickel, missing iron. This is the most unsettling. Nickel and iron are twins in stellar chemistry. You never see one without the other. Except in industrial alloys, 3i Atlas shows strong nickel, barely any iron. 5. Blue-green glow at low temperature. That hue shouldn't exist at its distance from the Sunday. Only electrical excitation or internal heating could produce that spectrum. 6. Perfectly aligned trajectory with planetary plane. Objects from interstellar space come at random angles. This one approached like it knew our layout. 7. Passage near Mars, Venus, and Jupiter. 3 major bodies. 3 unusually close passes, far closer than random chance dictates. 8. The lack of a cometary dust cloud. If it lost the mass required to produce its jet thrust, it should be surrounded by billions of tons of debris. We see none. 9. Highly stable spin rate. Natural tumbling is chaotic. Its rotation is consistent. 10. Radio silence, but plasma disturbances. No radio signals detected yet, but its interaction with solar plasma suggests strong magnetic structure. When you combine all 10, the probability of a standard comet becomes nearly impossible. And so I said the thing that started the firestorm. The natural model fits only with a likelihood of 1 in 100 million. Scientists don't like large numbers attached to their assumptions. But the data demands humility, not conformity. Something unusual happened this time. The public spoke before the scientific establishment did. Celebrities, politicians, teachers, students, they ask the question openly. Why hasn't NASA released the high-rise images of 3I Atlas? On October 23, the Mars Reconnaissance Orbiter captured the closest images of the object at roughly 29 million kilometers, with a resolution far sharper than Hubble. Those images exist. They sit on servers, waiting. Why aren't they public? We were told government shutdown delays, processing backlog, administrative approvals, but science does not wait for paperwork. ESA released their data. China released Tianwen-1's images. Ground observatories shared daily updates. Only NASA, the agency with the clearest view, has stayed silent. I have always believed that the sky does not belong to any government. What we observe belongs to everyone. That's why I submitted a public request. Release the 4 zero-day-old high-rise images. Let the world see what flew by Mars. If the object is natural, transparency cures fear. If it's not natural, transparency begins understanding. Either way, no one benefits from secrecy. People sometimes misunderstand what I mean when I say there is a 1 in 100 million chance that 3I Atlas is natural. It does not mean I believe the object is artificial. It means the natural explanation available to us right now fits the data poorly. Good science doesn't start with assumptions. It starts with evidence. Let me break down how we derive such probabilities. 1. We evaluate the typical behavior of comets. They redden near the sun bit. Their tails point away. They accelerate only from sublimation. They crumble in predictable ways. 3I Atlas violates all 4. 2. We assess the frequency of each violation. Most are rare at the 1 in 100 to 1 in 10,000 level. But all at once, that compounds the unlikelihood. 3. We compare against known anomalies. We only have 2 interstellar objects to compare. Oumuamua, Borisov. Oumuamua had unexplained acceleration too. 3I. Atlas is larger, brighter, faster, and more complex. A coincidence? Perhaps. But coincidences are just questions waiting to be answered. 4. We allow for alternative hypotheses, not conclusions, possibilities, like metallic crust, engineered alloy, detached probe, fragment of a larger craft, or an object shaped by non-thermal physics. Scientists disagree. That's healthy. But dismissing the unlikely before investigating it is not science, it's dogma. I prefer curiosity. Let's talk directly about the question everyone whispers. Could 3I Atlas be artificial? Here's my answer, stated simply. It is possible. We must treat it as a real scientific hypothesis, not sensational. Not dramatic, just honest. To dismiss technological possibilities out of hand is to blindfold ourselves. If 3I Atlas behaves like a craft, directional jets, controlled acceleration, stable rotation, metallic spectrum, unusual trajectory, then we analyze it like a craft. If it behaves like a shattered ancient world, we analyze it as such. Both are worthy of study. Both demand data. And That is why I have pressed NASA for transparency. Science is not harmed by releasing images. It is harmed by hiding them. There is no downside to transparency. There is no danger in letting the public see cometary fragments, if fragments they are. So what are the possible reasons for delay? Reason one, bureaucratic backlog. The most innocent explanation, likely true but not satisfying. Reason two, confusion over the anomalies. The images might raise more questions than they answer, and institutions sometimes delay what they cannot explain. Reason three, pressure to maintain a narrative. If NASA states it's a comet, but the images show behavior inconsistent with that, the agency risks losing credibility. Reason four, fear of misinterpretation. Officials may worry the public will leap to alien conclusions. But here's my counterpoint. People fear the unknown more than the unexplained. Transparency comes. Secrecy fuels panic. This moment is an opportunity, not a risk. Imagine a university releasing groundbreaking data. Imagine researchers the world over analyzing it in real time. Imagine inspiring a new generation of scientists. Isn't that what NASA was created for? There is something beautiful happening right now. The public is asking the right questions. Ordinary people, not astronomers, noticed inconsistencies. Why is the tail missing? Why is the color strange? Why is the speed increasing? Why are NASA's images late? Curiosity unites us. I once joked on air, Kim Kardashian asked NASA for transparency before many scientists did. It was humorous, yes, but also meaningful. Curiosity belongs to everyone, celebrity or citizen, student or professor. And when the public demands truth, institutions listen. That is why we must keep asking, why we must keep watching, why we must keep learning. Here's what the next few weeks look like. 1. December 19, closest approach. That is when we will see 3I, Atlas, at its clearest. 2. Fragmentation versus integrity. If the object is broken, we will see dozens of pieces. If not, the propulsion hypothesis becomes stronger. 3. Spin curve analysis. Stable or chaotic. That reveals structure. 4. Spectroscopic deep dives. Look for industrial alloys, carbon chains, metallic ions. 5. Plasma interaction. Monitor how the solar wind bends around it. Each test is a doorway. Every doorway leads to knowledge. And knowledge is the only cure for uncertainty. Let me leave you with a thought. If this object is natural, then nature has surprised us profoundly. It will require rewriting textbooks, revising models, expanding our understanding of interstellar chemistry. If it is artificial, even in the smallest sense, then we have just witnessed the first sign that another civilization once built something capable of crossing stars. But the most important thing is this. We must not pretend to know the answer before we look at the evidence. Humility is the heart of science. Curiosity is its engine. 1 in 100 million object is not a threat. It is an invitation to explore, to question, to imagine, to remember that the universe is not just a collection of rocks and gas. It is a story unfolding, chapter by chapter, anomaly by anomaly. And right now, 3I Atlas is the chapter we were lucky enough to be alive to read.